there's a blog post that was posted by Nikita Budakov, and this was in April of 2020. And so he was talking about how they build robust anomaly detectors with machine learning. So anomaly detectors apparently are these things that they are able to use to try to find anomalies. And I'll try to be a little more specific about what that means. So this is their kind of definition, formal definition of what anomaly detectors are and what they're actually used for. So it has kind of a lot of lingo in there, but you might want to read that. And then their real life example of like where and why you would need this is here. So consider you have a customer that's logging into a service provider's website and they want to add more data to their cell phone plan, for example. And then upon submitting their order, the website times out. So of course they're gonna call tech support, but when they call tech support, maybe it's not clear to the tech support person where the application, where in the application stack the error is occurring. So they can't figure out, you know, why did this happen and where did it happen? So in terms of this process, this is a really like long labor intensive process for the person on the other end of the phone to try to figure out what's wrong and try to diagnose the issue and help this person. However, they could be assisted by something like an anomaly detection framework. So something that could point out, this is where the anomaly occurred. This is where something strange happened. And this is where you should start by looking to figure out where something went wrong. So by getting models that can help to detect these anomalies, then we're able to resolve incidents faster. So they're able to get people on and off the phone with the IT people more quickly. And of course, so in reality, no anomaly detector provides 100% yes or no answers. It's not 100% of the time going to say, this is an anomaly, this is the problem. There's always false positives and false negatives. And there are trade-offs between false positives and false negatives. So just like what we've been learning where we have a hypothesis and then we're testing a hypothesis. So here the hypothesis would be, is this an anomaly? So it's a little bit different. This is an extension of what we've kind of learned in class, but it's using a lot of the same tools that we've used. So they call this just like a baseline univariate anomaly detector, and then they go over the steps to construct this. So first, you calculate the mean. So just arithmetic mean just means the regular mean, and then the standard deviation of whatever metric you're using. So you have some metric for this website or whatever it is, and they calculate the mean and standard deviation over a sliding window. So basically that means instead of just calculating the mean and standard deviation over the entire time period, you pick, for example, like a 2-hour time window, and you calculate what the mean is and the standard deviation is in that window. And then you move over a little bit and calculate the mean and standard deviation in that window. And then you move over a little bit and keep going like that. So you're getting a bunch of different, what we're going to assume are normally distributed random variables. So now we have, in a window, we have a mean and a variance, and we want to know, we have this specific value within that window, is this an anomaly? So we calculate the z-score for that location. So for example, maybe this point right here, we would want to calculate the z-score for that. And so we would look at, okay, what is the mean and variance of the normal distribution within like a 2-hour time frame around this? And then if we calculate the z-score, where is that on that distribution? How many standard deviations away from the mean is it? And so then, of course, we can use that to classify points as anomalies if that z-score exceeds a predefined threshold, which is the same thing as using the p-value to say if the p-value is less than a predefined threshold, then we're going to say that we'll reject the null hypothesis that this is not an anomaly. And this is different. This is a different way of doing it using the z-score instead of the p-value, but it effectively does the exact same thing. So for example, z-score of 3 would correspond to 3 standard deviations away from the mean if we assume normally distributed. And so that's a good starting point. And of course, in practice, the threshold value should be set following statistical and domain considerations. So there's going to be some norms within your within the context of your company or whatever it may be, context of your specific problem. So that's the beginning of this article, and then they proceed to talk about problems with this. So you can see that the mean and variance are very easily influenced by this one anomaly. So that's one issue that they talk about. And then they talk about, okay, what's ways that we can kind of adjust this process and come up with new procedures that can better be used to detect anomalies. Starting with this, just like the baseline procedure, which is something that we're pretty familiar with, and they get into more using medians instead of means, and they start talking about other machine learning approaches. So it's pretty cool article, and if you want to check it out, it's right here, and I'll link to this in the email as well. All right, have a great week, everyone.